Okay, we're going to take the notes on relative dating before we continue on with the superposition examples. All this information is part of your geology notes. Roman numeral 1 was geologic time, geologic time. Roman numeral 2 was relative dating. All right, this is how scientists know what happened in Earth's history. One of the techniques they use is through relative dating. So, to discover what happened in Earth's history, we need to look at the evidence that we have left. Well, relative dating was one of the terms that you had to define for science vocab several weeks ago. And it's just like it sounds, it's finding the age of an object, but only in comparison to something else. You really don't give it an age, you just tell if it's older or younger than something else. So it's determining if an object or event is older or younger than another object or event. Okay, so it's like saying that this fossil is older than that fossil. Well, how do I know that? One of the techniques or the tools that scientists use is called the geologic column. Again, it was a term that was part of your science vocabulary several weeks ago. The geologic column is like a key. It's defined as the ideal sequence of rock layers. So by ideal, it means that if we had all rock layers from all around the world, they were all in one place, and we put them in order, that would be the geologic column. It's like a key or a guide. So every rock layer we know about, we've put into this geologic column with the oldest ones at the bottom, because they would have been laid down first, and the youngest ones at the top. So it's ideal sequence of all rock layers, including all known rock formations and fossils on Earth. Capitalize that. All right. So when a scientist finds a fossil or finds a rock layer, a rock sequence, he can look at the geologic column for a particular area, and he can say, well, this rock sequence is this old because I have this key, this geologic column to use. And I mentioned before, and what we've been working with is the idea of superposition. And it's really a common sense idea that the oldest rock layers will be on the bottom and the youngest rock layers will be on the top. And you might think, well, how do you get to those oldest layers if they're buried underneath? Think of the Grand Canyon. When you're looking at the Grand Canyon, the canyon itself, you're looking at millions of years of rock layers. When you drive down I-75, if you've ever driven from Ohio to Florida, and you look at the mountains that you cut through when they had to blast away to make that roadway, you're seeing millions of years of rock layers rising up on either side of you. So scientists use the knowledge they have of the geologic column and of superposition to give a relative age to unknown fossils. So superposition is that younger rocks lie above older rocks, but that's in undisturbed sequences. That means that only holds true when the rock layers haven't been disturbed by anything. The Grand Canyon, you're looking at million years of rock. Well, but some of that rock has been disturbed and disrupted. So it might not necessarily hold true to the idea of superposition. The catchphrase for superposition is younger over older. Again, that should just make sense. But remember, that's only when the rock layers are not disturbed. Well, what this next section we're looking at is going to focus on what disturbs the rock layers. Well, first of all, a disturbance is any change in existing rock layers. Disturbances disturb, which you shouldn't use the term in its definition. So it's a change. Disturb or change existing rock layers. So messes them up in some way, puts them out of order, or introduces something else. One type of disturbance is a fault. You should be familiar with that term. A fault is simply a cut in the layers. And I'm getting this information from that book, that textbook page 61, where you were to find the definitions for. So a fault is a cut in the rock layers. An intrusion, just like the word implies, to intrude on something is something that doesn't belong there. Well, when you're talking about rock layers, an intrusion is when magma squeezes between their layers and hardens. They call it solidifies. So now you have this piece of rock in between rock layers that doesn't belong there. It squeezed in between them and it became a section of rock that doesn't belong with the other rock. Folding is when pressure creates a bend in the layers. And you will really actually see a bend or a fold in the rock layers. And finally, tilting is when uplift creates a slant in the layers. So you see the actual layers and they're slanted, they're tilted on their side, okay? So these here, 2 through 5, are the 4 types of disturbances, things that can disturb superposition. They can disturb rock layers. And one thing you need to remember that will come up later, the rock layers had to be there first in order to be disturbed. That's another idea in relative dating. And again, it's a common sense idea, but too often it gets overlooked. So I have these rock layers, well, they had to be there first, and then the faulting event occurred, or then the intrusion occurred, or then whatever folded or tilted the rock layers occurred. Because when we look at rock samples and rock sequences, often you will see layers themselves, then disturbances, and then layers on top of that. And that's all the idea of relative dating. Trying to determine what came first, this rock layer or maybe this event that disturbed the rock layers. So for today, you're just taking these notes. Then tomorrow, we're going to look at how we're going to disturb our superposition examples. All right.